Scenario: an amusement park ride has identical carriages that revolve around the center of the ride's axle, as shown in the figure. Both carts travel at a constant tangential speed at all points along the circular path with a radius r. Question: if a rock is dropped from point 1 and falls directly downwards to point 3, what is the kinetic energy at point 3? Answer: the approach is to use conservation of energy because the total energy at the bottom is going to be the same energy as the top. Energy at cart 3 is equal to the energy of cart 1. At cart 1, there is both kinetic and gravitational potential. So there is a 1 half mv squared, which represents the kinetic energy at the top. The mgh represents the gravitational potential at the top. Notice that the height here can be determined by 2r because that is the total distance from the cart 1 to cart 3. It travels 2r, which represents the diameter of the circle. Substitute it in for h, you get this value. You can now see it is equal to 1 half mv squared plus 2 mgr. This is one way you could see it, or you can actually factor out a 1 half m. As a result, you would have 1 half m parentheses v squared plus 4gr. Please note that the 2 mgr value that's right here describes the kinetic energy that comes from the decrease in the potential energy of the rock earth system that is gained when it drops straight down. So that's why there's two sources of energy for the cart.